In this video, we will discuss about the issues related to stale or outdated statistics and its impact on query optimizers' ability to estimate rows for incoming queries. We'll be using AdventureWorks DW database for this demo. I'm going to create a new table called table1 underscore temp, and the data for table1 underscore temp will be coming from the existing object table1. So let me first drop the table and then recreate it. So now what I'm going to do is I'm going to execute this particular query, which basically gives us the count of rows from table1 underscore temp with the predicate column 4 equal to 11 January 2024, 8:32 p.m. 5 seconds. So let's execute this query. So we see that 5,099 rows are returned. Let's look at the execution plan. We have a table scan operator on table1 underscore temp. Let's hover our mouse there, and then we can see that we are estimating 5,099 rows and then returning close to 5,099 rows. So it's a perfect estimate as far as this particular query is concerned. So what we can see is table1 underscore temp has got close to 5,099 rows. If we see here 5,099 rows with row value with column 4 value as 11 January 2024, 8:32 p.m. 5 seconds. So let's look at the statistics available for this table, and what we are able to see is there is an auto created statistics on column 4 for on table1 underscore temp, and this statistics was created when we executed this query. So now what we'll do is we know that with this predicate value in column 4, we have close to 5,099 rows on table1 underscore temp. So what we'll do is we will try deleting close to 5,000 rows from that table1 underscore temp. Once we delete that, we will be having close to 99 rows. Yeah, let's go ahead and delete 5,000 rows. And then now what we'll do is we will go ahead and execute the same query that we have previously. So previously when we executed before the delete statement, we estimated close to 5,099, and then we end up returning 5,099. So it was a perfect estimate. Now we have deleted close to 5,000 rows with that value. So what we'll do now, let's execute the query and then check what is the estimate now. So we deleted 5,000 rows, so we end up returning 99 rows. But let's look at the estimates as far as the table scan on table1 underscore temp is concerned. So this time I'm no longer estimating close to 5,099 because the optimizer understood that there were changes on this particular table. So what it is done is it is intelligent enough to understand that, and the estimates have come down from 5,099 to 4,884.56. So let's put that here, and then let's see from where he got this estimate. So just to check that again, it is 4884.56. So now what we'll do is we will look at the list of statistics, and we will pick up the statistics related to column 4. Let's put that across, and then what we'll do now is we will execute that, and then let's see how did we get the estimate of 4884.56. So we know that the predicate is 11/1, that is 11 January 2024, 8:32 p.m. and we know after the last statistics update, we have made the changes. That is, we basically deleted close to 5,000 rows on the table. So we will basically be doing an selectivity calculation, and then we will be multiplying it. But for that, what we'll do is let's look at the histogram steps and see if we have a direct hit. 11 January 2024, 203205,140. So here we basically have an direct histogram step hit, and for this one we basically are looking at a row of 5099. So what I'm going to do is like I'm going to calculate the selectivity here. So what I'm going to do is like I'm going to divide the number of rows that passes through this particular table using this predicate divided by the total number of rows that is present on this particular table. So, and then what I'm doing is like whatever value that I'm going to get will result in the selectivity. And then I will multiply that selectivity value with the number of rows that is present on the table. So let's execute that. And the resultant value is 4884.5575, which is basically, if you round it, it is 4884.56. So what we'll do now, we will execute this query one more time along with this selectivity value, and then check it one more time. So basically what I'm doing here is like I'm basically dividing the number of rows that is basically flowing through the table 1 underscore temp based on this particular predicate divided by total number of rows that is present in table 1 underscore temp. That basically gives us the selectivity value. Once we have the selectivity value, I'm multiplying the selectivity value with the total number of rows that is present in table 1 underscore temp. So let's execute it. And then we know that the estimate value that we calculated is 4884.55. And and let's look at the execution plan here. And if you look at it here, the execution plan is, so the estimation is 4884.56, which is same as what we have calculated. So the optimizer basically did this particular calculation using the selectivity value and multiplying with the total number of rows to come up with the estimate for this query after we deleted some rows from the table. And this basically become an outdated statistics after we deleted a huge lot of rows when compared. For example, you had 5,900 rows and we deleted close to 5,000 rows. It is close to like 95% of the changes, or as far as this particular table is concerned, at least for that particular predicate. So what happened is like since the statistics that we had was outdated, we came up with an estimate, which is kind of a higher estimate, where we estimated close to 4,884 rows, but we ended up returning just 99 rows. It's kind of waste of resource, because what happens is like when you estimate huge rows, there is high possibility you might be utilizing or allocating resources as per the estimates. But when we are about to just return fewer rows, what happens is like the resource that is allocated kinds of becomes waste, and this can lead to some concurrency issue. So what we'll do now is like we will try resolving this outdated statistics by updating the statistics on this particular table. And then let's run this query one more time and then look at the estimates. So now we are having a perfect estimate where we are estimating 99 rows, and then we are returning the estimated rows only. So let's look at the statistics, and then let's go to the histogram step. So it is 11 January 2024, 8:32 p.m. 05. So if you look at it here, it is basically like we are estimating we are estimating like 99 rows. So we don't have a direct histogram step hit. If you look at it here, it is 11 January 2024, 20:30, that is 8 p.m. 8:32 p.m. 06 seconds, but our predicate is 05 seconds. So here we are basically going to use the average range rows, which is basically 99. So if we execute this query and look at the estimates, we have a perfect estimate wherein the average range rows in our case was 99, and we estimated that value here, and then we ended up returning that 99 rows. So there is a perfect estimate here after updating the statistics. That's it for this video. Thanks for watching. Have a great day. Jai Hind.